Alrighty, we are in Note 6, getting towards the end of Unit 6. We have this set of notes, two more, and then you'll have your summative. So we're getting towards the end. We're combining a lot of our ideas. And in this set of notes, what we're really doing is making sure everything comes together into one simple idea. Y equals mx plus b. So y equals mx plus b can be a table, it can be an equation, and it can be a graph. It can be all three things. This set of notes are going to finish up with a applications question. So I want to make sure you're confident and you follow everything I do up until this point, and that question should be pretty easy. So let's go ahead and get started. Let's do it. So as always, we're going to start with a test your knowledge. I'd like you to try plotting these two y equals mx plus b questions. I will show you how to do the first, and you can try the second yourself. Remember, instead of trying to plug in a bunch of x's and y's, I showed you how to use rise over run. You can use rise over run to plot an equation easily without having to do a whole lot of math. So we're going to start with our first y equals, that's going to be y equals negative 3x plus 4. This is my y-intercept. So I'm going to start with that. That means my line is going to cross at 0, 4. It's going to cross the y-axis at 4. Then I'm going to use rise over run to plot the rest of my line. The slope of negative 3 is going to be the same as negative 3 over 1. That means I fall 3 and then run 1. So 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. And I can't go further this way or that way. So I can connect these points and draw my line. I'm going to use a note card to draw my line. You can do the same in your notes. Just let me know and I'll be happy to give you a note card. Look at that. A nice clean line. So I want you to try this one yourself. You're going to want to plot the y-intercept. Then you're going to want to use rise over run to plot this slope. This one's going to be rise. It's positive, so it's going to rise instead of fall. So go ahead and pause, give it a shot, and I'll show you how to do it once you're back. Okay, so you're going to start by plotting your y-intercept at 0, negative 2. And then you're going to use your slope of 1/2. You're going to rise 1, run 2. So rise 1, run 2. Rise 1, run 2. Rise 1, run 2. Now, going the other direction, we're going to run first, then go down. Run 2, fall 1. Run 2, fall 1. Run 2, fall 1. The reason we're doing that is to recreate the same pattern in both directions. Okay, I'm going to use my note card to connect. And that is how you plot a y equals mx plus b. It's the same as what we did before, but this time you've got a y-intercept. It's not going to cross the origin in the middle. So, at the end of Notes 5, we briefly discussed translation between a line and an equation. These notes are really meant to reinforce that idea. By the time these notes are done, you should be able to translate between a table, an equation, and a graph. So I have an example here, and in this example, all three are already represented. I'm going to show you the steps and what you do to go between all three of them. We're first going to start with a table. So let's say we want to make an equation, a y equals mx plus b equation from a table. Ultimately, what you're doing is finding the y-intercept and finding the pattern. We're going to use the slope formula to find our slope, m. And we're going to find our y-intercept by figuring out what y is when x is 0. So we're going to start with the y-intercept. When x is 0, y is 2. That means this is our y-intercept. Okay. We're already halfway done. We have our b. All we need now is our m. We're actually going to use the same point. I'm going to call this my old point. I'm going to take 2, 1 as my new point. Okay. So I have an old point and a new point. I'm going to use my slope formula. So y new, 1 minus y old of 2 over x new of 2 minus x old, 0. That's going to be negative 1 over 2. and that's going to be my m. So we have our b, we have our m. That's going to give us y equals negative 1/2 x plus 2. And wouldn't you know it, that's the same thing I have right there. This table is the same as that equation. Then, let's say we wanted to plot a graph from our table. All we do is we plot the x and y's as points, then connect them. So for example, we have an x value of negative 4, 4. Negative 4, 4. There's a point right here. At negative 2, our y is 3. Negative 2, 3. When our x is 0, our y is 2. When our x is 2, y is 1. And when our x is 4, our y is 0. So we just plotted a bunch of points. Obviously, that's on our line. But if we wanted to connect them, we would draw the exact same line. So as you can see, getting a line, getting an equation and a graph from our table is pretty easy. We can do the same thing from an equation. To make a table from an equation, we plug in x values and we get out y values. So let's say I wanted to plug in negative 4. Negative 4 times 1/2 is positive 2. Positive 2 plus 2 is 4. Okay, that's the same points we got at our table. If we plug in negative 2, negative 2 times negative 1/2 is positive 1. 1 plus 2 is 3. Okay, but if we plug in 0, 0 times negative 1/2 is still 0, and 0 plus 2 is 2. And you'll see that if we just draw a line here, draw a line on the top, we're pretty much creating the exact same table you see on the left. We can keep on going. We would get 2, 1, 4, 0, and we could go even further from that if we wanted to. Now, creating a table from an equation is easy. So is a graph. So we want to start by putting a point on our y-axis based on our y-intercept. So here in our equation, if we wanted to draw a graph, we'd put a point at 0, 2. Then we use our rise over run to get the other points. Our slope is negative 1/2. So we fall 1, run 2. So from this y-intercept point, we would go down 1 over 2. Down 1 over 2. Down 1 over 2. We can go the other way. Over 2, up 1. Over 2, up 1. So, from an equation, we can get a graph. From a graph, we can make a table. We find the points on the line and fill tables with each x and y. So, let's start with our point all the way on the left. When x is negative 4, y is 4. That's the first value on our table. When x is negative 2, our y is 3. When our x is 0, our y is 2. These points are filling in from our line. When x is 2, our y is 1. When x is 0, when x is 4, y is 0. This table is that graph. So if we wanted to get an equation from the line, we would use rise and run to find slope. We use our y-intercept to find b. So here, our y-intercept is positive 2, so our b equals 2. Our slope is rise over run. We fall 1, so our m is negative 1, and we run 2. Fall 1, run 2. Fall 1, run 2. Our m is negative 1/2, our b is 2. So we can create the same equation, y equals negative 1/2 x plus 2. And that's the same equation here and here. All three of these equations are the same. So, we can go between a table, an equation, and a graph by just reorienting our x's and our y's and finding our y-intercept. So take a second to take it all in. Think about how we went from one to another. Then I want you to go to the checking understanding here at the bottom and try creating a graph and an equation from just this table. I know you can do it. Give it a shot. Once you're done, we're going to flip to the back. And I'm going to show you all you really need to create all these things is just your y-intercept and a point. Notice here, we only needed our y-intercept and our point, and you can get everything else from there. So, how do we do that? Really, all we need is a point and the y-intercept. From that, we can get an equation, and from there, a graph and a table. Isn't it amazing how we can figure out so much from so little information? We're going to start with a question. What is the equation of a line that connects 0, 6 and 2, 0? First, notice that one of our points is our y-intercept. Part of our y equals mx plus b is already done. This point, 0, 6, its x value is 0, so it's our y-intercept. Our y is 6. I'm going to go ahead and fill this information here, that our b is 6. And at the bottom, I'm going to fill in the equation. We have plus 6. That means all I have left to get is my slope. All we have to find is our slope, which we're going to use the slope formula to find out. It's going to be y new minus y old over x new minus x old. So I'm going to label this my old point. This is going to be my new point. So that's going to be 0 minus 6 over 2 minus 0. This ends up being negative 6 over 2, or negative 3. That means our slope is negative 3, and we've finished our equation. Y equals negative 3x plus 6. Once we've got that, we can fill in the graph and the table. Our y-intercept is 6, so I'm going to go ahead and put a point at 0, 6. And then I'm going to go ahead and plot my line by doing rise over run. Negative 3 over 1. I'm going to fall 3, run 1. So we're going to go down 1, 2, 3 over 1. 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 I'm going to use my note card to connect the line. Okay, a nice even line right there. And I'm going to use these points to fill out the table. My first point is 0, 6. My second point is 1, 3. My third point is 0, 2. My fourth point is 3, negative 3. And my fifth point is 4, negative 6. And that's everything. We got all that information from just a point and the y-intercept, which is going to take us to our checking understanding. It's a little bit of a word problem, but I know you can do it. You're going to be given a prompt. For your birthday, you got $100. You've been spending it. A week later, you check your wallet and find that you have $65 left. If you keep spending at the same rate, after how many days will you spend all $100? You're going to think of Y as your money, and you're going to think of X as days since your birthday. So to fill out this process, you're going to do 6 steps. You're going to turn this information into a pair of points. One of them is going to be your y-intercept. Figure out which is your y-intercept. You're going to figure out the slope. You're going to make a y equals mx plus b. You can graph it. And you're going to try to figure out where your money runs out by finding where the line crosses the x-axis. Okay, so give it a shot. It might be a little challenging, but I know you can do it. And make sure you ask me questions when you need help. I'm more than happy to help you. So that's it for this video. Thanks a lot, and as always, have a great rest of your day.